I thought I'd show you how to program an Entel DX series radio. Now, DX series is a digital radio. DMR is the standard it uses. Now, modern radios, when I mean modern, I'm talking last 30 years, don't have crystals in. Crystals were the old-fashioned technology which you'd buy for a specific frequency and you'd install them, and that's how you program them. Modern radios, you hook them up to a computer, and it's developed over the years. The programming is a lot easier with modern equipment. You don't need a telecommunications test set necessarily to plug it into like you did in the 90s, because the software and the whole thing has become more user friendly. So, saying that, I'm going to show you the Entel programmer. Right, now, as I say, this is used for the DX series, so I'll just look for it. So, Entel programmer. Here we go. Right, let's boot this thing up. So, right, so this is what you get. Got your license wizard and your license free. Now, license wizard, that's for the radios, the higher power radios, putting out 4 or 5 watts depending on the frequency band they're running on. That you need an Ofcom license for, which we can help you with. The license free, that is your PMR 446. Now, PMR 446 is a standard for license free radios, which is usable in most countries in Europe, including the UK. So you don't need a license, you can just buy them. They're set to frequencies already, press the button, off you go. Disadvantage, they're lower powered than the licensed ones, and therefore you're not going to get the range. Of course, the signal range depends on a number of factors. The signal gets what's known as attenuated. Now, buildings, hills, all sorts of things. Metal buildings are bad because radio waves don't like going through metal. They don't. There's ways around this, of course. Same with hills. Signals above 30 megahertz, which we use for which these radios run on, won't go through hills. So we use things called repeaters, which can be linked up to this radio. Anyhow, right, let's click on License Wizard. I'll show you rather than me talking about it. And you'll see this comes up. So we can give it a fleet name. Blogs, cakes. No idea if it's a blogs cakes, but let's pretend. And select your application type. Now we've got land. I've got various options: land and marine. UL2 and 3. You can see there's an American standard. Right, land. So let's go for land because we're going to be operating these on land. Frequency range 400 to 470 in brackets UHF. UHF is short for ultra high frequency, and right, tell you what, I'll click on the next thing. See, right, you can see here we've also got VHF and we've got high UHF. So VHF and UHF. Right, now you may notice if you looked at a UHF radio, a UHF, in this case a DX series, and a VHF one, that the antenna on the VHF one is longer. It's longer because VHF is at a lower frequency on the electromagnetic spectrum than UHF. So the lower the frequency, the longer the wavelength. They're sort of inversely proportional to each other. That is why the antennas are different. So if you have what's known as a quarter wave, which is a quarter of the wavelength, an antenna at VHF, it will be a longer antenna than a quarter wave antenna at UHF. That's why some of these UHF antennas are really quite small. And so just remember that you could normally, if you look at a radio and it's got a short antenna, it's more likely to be UHF. And if it's a bit longer, it's going to be VHF. Right, let's select this to UHF and enter your read password, which is optional. So we could put a password in. This might be useful if you're supplying to a company and they're a bit concerned about security, because if the radio's got stolen or lost and someone wanted to reprogram them, well, if they don't know the password, they can't. So it's effectively useless to them, which might help, and it also might help identify the radios if they're recovered. And I mean, you hopefully would know the serial numbers, but if not, you could prove they're yours by putting in the password. So let's go down here a bit. So DX482. Now DX482 is a UHF radio. DX485 as well. As you can see the difference there, DX482 doesn't have a screen. The DX485 does. And there's also some other radios we could program here listed. So let's do a DX485 because I've actually got one of these I can plug in. Right, so let's set up radio type and quantity in this fleet. Right, it doesn't mention fleet with one radio, let's have two. Okay, so if we go across here to the right, the fleet requires digital and analog channels. Now, digital, like I say, is a DMR standard. It's a different way of transmitting the signal compared to the older analog system. It's more secure, it works better at the sort of fringes. On an old analog radio, you can tell the difference because the signal will start breaking up, it'll sound crackly, whereas digital, it either works and it sounds exactly the same or it doesn't work. So that is one way you can tell. If you've got a radio and it's cutting in and out again, that's analog. Right, great impression. So do we require digital analog channels? Well, the other option is this fleet requires analog channels only. We don't want that, we want digital, so we'll stick with this. This fleet requires only a single group for group calling, so we can set the thing up as we wish. You might have groups if you're if you're a hospital, you might have groups for the porters, for the security, and etc. So you can set people up into groups. Right, the fleet does not require individual calling. We'll leave that for now. We've also got emergency calling, we've got zones, etc, etc. Right, okay. So the fleet requires emergency calling setup. Please select how many emergency systems are required. 1. Go. Right, now here you go. At the moment, RX is our receive frequency, and it's set to 450.5 megahertz. Underneath it, you'll see RXCC. Now, CC stands for color code. Okay, and it's set to 0. Color code in digital radio is like CTCSS or DCS in older analog radios. What it does, imagine it's a key. Imagine you've got a key for a lock. Now, the radio signal can't get through the door because it's locked. Now, what the CC, this color code, is doing, it's providing the correct key to open the door so you can hear the other person. If you don't have the correct key, you can keep pushing against the door, metaphorically, with your signal, but it's not going to get through because you haven't got the right key. So it's a key, basically. So you could have various people using the same frequency, but unless you've got the right color code between two radios, you're not going to hear each other, which is good. if you turned the colour code off, you'd hear everything on that frequency. Right, now next to it we've got TX. TX 450.5. So it's the same as the RX. So RX is receive, TX is transmit, and they're on the same frequency. This is known as simplex. So the transmit and receive are on the same frequency. There are alternatives to this where the transmit and receive will be on different frequencies. Now you might be thinking, well, how's that going to work? Well, you use it in conjunction with a radio repeater. So you may transmit on, we've got here, let's ignore the receiver. You may say, imagine that RX was 460 and that was 450, just for argument's sake. The handheld radio would transmit on 450.5. The repeater, which is a device that receives a weak signal and transmits a stronger signal out, therefore boosting range, would receive your transmit. So the receive on the repeater would be set to what the transmit on the handheld radio is. So it received a signal and rebroadcast it. And we said that 450.5 is now we're pretending it's 460. So the repeater would transmit on 460. So it would receive on the transmit frequency from the handheld and rebroadcast on the receive frequency from the handheld. Does that make sense? So yeah, so the signal will go to the repeater, it'll be boosted and then transmitted back on the receive frequency of the handheld so you could hear it. Right, okay, what else have we got here? TDMA, time digital multiple access. Okay, so time slot 1, it's a way of splitting with these digital radios. You get two time slots effectively. So you're able to transmit. I'm not getting muddled up. I'm thinking how to explain this. You can transmit. You're on the same frequency. In this case, 450.5, but you could have two conversations at the same time. It's splitting the channel up. Remember, it's called time division multiple access. So we're dividing the time up really quickly, so you're not really noticing it, between the users. So we're in slot 1. So therefore, we can have a conversation on slot 1 and conversation on slot 2 at the same time. So we've effectively got two channels. Right, what have we got here then? BW, not BMW, BW. Right, 12.50 kHz. Now kHz is kilohertz. Okay, so 12.5 kilohertz. Now that is the bandwidth of the channel. That's in UK that's a standard, or pretty much that's a standard bandwidth, the width of the channel, of the frequency. So if you apply to Ofcom for frequency, then they say yes, you can have 470.5 megahertz. That is your frequency. You've only got 12.5 kilohertz. You can't think, oh, I'll have, what do I say, 470.5. You can say, well, I'll have 470.5 to 480. You can't have a great big channel like that. Other people need to use the frequencies. So your frequency that you've been allocated is 12.5 kilohertz wide. And right, what else? I was going to say something else, but that'll do for now. So BW is bandwidth, TDMA, time division multiple access. You've got effectively two channels within that 12.5 kilohertz bandwidth. Right, we've got here RF channel alias. Again, like most of my videos, I never plan this. I just turn the camera on, so I haven't really got a script. So if I'm pausing, it's because I'm thinking it through. yeah, I'll just make it up as I go along. Right, RF parameters. I mean, this software is quite good, quite user-friendly, this Entel software. Some of it is harder to use. This has been designed to be used, well, pretty much you could argue, to get rid of the two-way radio dealers, because radios normally, they come with a specific programming lead that you have to buy. The advantage of the Entel DX series is you can use a standard USB lead to mobile phone lead. That's what I use. Actually use my smartphone programming lead for programming, because it just plugs into the laptop and you plug the other end into the radio, and it's not a specific lead for a specific radio, which most other manufacturers do, and it's quite annoying because it costs you money. So it's okay if you're selling lots of one radio, but if you're selling one, just hit the microphone. If you're selling one or two once in a while, it's hard. It is worth it, but it's quite a big expense, especially things like Motorola leads. They're quite expensive. Some of the programming kit for Motorola is like £150. That sort of price, quite expensive. Whereas this, you could just plug in, use a mobile phone lead, and it makes it a lot cheaper and simpler. So what we've got here, RF parameters. RF being radio frequency. Parameters, frequency 450.5, which is what it's come with. Now we can change this by clicking on it. Let's go to 460, and let's. And I've clicked on that, and it's now swapped across to match it. Now you can change it to something different, like that. So we're no longer simplex. We're no longer on the same transmit receive frequency. We've now got a different. Now in reality, you wouldn't have that much of a gap. You wouldn't have 20 megahertz between the channels. Ofcom wouldn't do that. Now I said color code. Color code. Frequency is out of supported frequency. But yes. Then we go. It's because I've selected standard UHF, and this blowing up to 470. So, okay. So receive, we've got 460. Let's give it 470. I think it's going to be 470.000. Right, now let's try it. Color code. So now we've got 10 megahertz between our channels. Now you can select what you like. You need to not be on the same color code that someone else in the area is using if it's a shared frequency. Otherwise, you're going to hear each other. So I've gone color code 6. Right, that makes it receive only. Why is that? Right, I see. I was just thinking, why is that blanked out? Well, it's blanked out because we're on the same frequency now. So there's no point change. We're on simplex. We wouldn't have a different. We'd have the same color code. Right, let's go. Just make it up. 440. Interesting. Right. Slot 1. Right, what have I done along here? Of course, ignore me. Brain's gone to sleep. You're not. Yeah. So we just set to color code. It's the same for receive and for transmit. Right, but you can see there we've got different frequencies now. We've got receive 460, transmit 440. I just made these frequencies up, so we won't actually be transmitting on this because we'd be breaking the law basically. Right, TDMA, and it tells us about it here. A DMR. Digital mobile radio. So DMR is probably the most popular worldwide standard for digital business radio. DMR frequencies split into two separate talk channels, slot 1 and slot 2. And as I said, it's TDMA, time digital multiple access, using repeater. And using repeater, both slots can be used at the same time. In simplex, to achieve simultaneous use of TDMA, direct mode must be set to 1, 2 or 3. Right, Transmit power settings, high or low. High, I think if we're looking at the DX482, UHF are normally about 4 watts. But if we were comparing that to the PMR446 that I talked about earlier, which is the license free, that puts out about 500 milliwatts, or half a watt. Now, there's not a direct relationship between the power, so if you had the radio putting out 1 watt rather than half a watt, it doesn't mean the signal is going to go twice as far, but it will help penetrate objects. Right, what's this? Channel admit criteria, always. Yeah, so the radio will transmit whenever the PTT, that's push to talk button, is pressed, or you can set it so it will only transmit when the channel is free. And right, okay, TX TOT. Now TOT is a timeout timer. So if you're talking and you're discussing what you're having for lunch and it's not really very business-like, and you go over 90 seconds, it'll automatically stop you transmitting. Now part of it is to protect the radio from not getting overheating or being strained. Transmitting also uses more battery than receive. But the main thing is you might be hogging the channel. If you've got the admit criteria where you can only transmit when the channel's free and someone wants to make a conversation, make a call with someone else, and there's someone talking about their lunch and the dog or whatever, yeah, you want it to cut them out, and you see it says TO timeout penalty 5 seconds. So there'll be a 5-second gap before they can talk again once it cuts them off. So therefore, giving someone else the opportunity to come in with their message. That's what that's about. Right, and we've got a zone. That symbol there I'm pointing out, I'm hoping this mouse pointer's enabled. In the video settings, otherwise you won't know what I'm talking about. So we've got digital, one talk group. Right, so allocate to the zone. That digital RF channel 01 is that. You can put it, we've got various settings here. We can have contact pools, receive group lists, emergency with alarm, roaming, etc. Right, but this is really just to show you what the programmer software looks like. We're not going to go too into it. Right, so there you can see we've got a channel saved to channel 1, and we can add various channels. So I can click on here to add a new channel preset, double click even. Right, now what it's done here is just copied that one, but you can edit these. You can put in what you like. Okay, so it's coming next. Then we've got the button allocation. So this is a Entel DX 485 with the screen. So short press, which is orange button. Now the orange button is on the top there. Hopefully you can see my mouse pointer. Now you can set that for a variety of functions you've got here. You've got key lock, change the TX power level, monitor squelch defeat. Now squelch, if you're using it as analog, it will only allow you to receive a signal over a certain strength. If it's below a certain preset strength, the squelch will keep it silent. You won't hear it. So that's what that's for. Low battery, lone worker, on and off, man down. So emergency functions. Scan, you can scan a number of, running through scanning a number of channels you got programmed in, listening for messages. Right. Same with that. So all these are allowing you to program the radio buttons. You've got buttons on the side here. Give an advanced user interface. Right, and you can see if you look at the screen, if you look at the picture of the radio, this basic UI is changing what's going to be displayed on the screen. So basic UI, it says CH01 digital. So channel 1 digital. Right, simple UI even. Right, we've got some information here about sort of like talk groups now at the bottom there. It's like we've got battery, things like that. Do we have battery on there? Oh, we have battery on the simple basic as well. And then we can click to advanced, and it's telling us our zone, our channel, our group. So, depending on what sort of information you want, it's all programmable. Right, finish. First time run, fleet management screen, right. Okay, now in the corner here, which I can't see because my light is pointing at, you've got now your two frequencies we've got programmed in, and what you do is you can, so what do they call it, a DX482 in it, yeah, no, it's a DX485. So add new radios. You can add a radio to your group, and you can program it. Don't think it's going to work. I haven't actually got the radio plugged in yet. I'm going to stop the video and go and get a radio. Should make more sense, which is what I should have done before I started this. Right. Radio. Utilities. Programming window. Here we go. Ah, it's down here now, in the wrong place. Firmware upgrade, reconfiguration, right. So you see on the screen, did I pressure cut? I must have done, yeah, of course I have. Right, so, firmware upgrade. License, no, hang on. Why does it say it's not licensed? It is. Let's read the configuration, let's do that first. It's not. Do you want to read anyway? Yes, I know it's not in the current fleet, but yes, we'll read it. Into new fleet, yeah, whatever. Blogs, cakes, right. Okay. We can. Top corner. Enter the read. I hope I can remember what this is. Right. Let's have a go at this. Right. I'll have it written down somewhere. Start read. Hurrah. So. Right. And it's read it. So. DX485. Alias YesWay1. Oops. Password. Right, just seen the password, never mind. It's not very exciting. It's just a name of someone I know. Right. Okay, so the DX485. And there's right. So there's a serial number. There's the preset channels. Won't leave them on the screen too long. Contact list. Right. So we've got. That is reading all the channels we've got loaded in into the radio currently. I can't even remember what these channels are. I think some of them might be even amateur radio channels, because I've got an amateur radio license, so sometimes I use it for that. Some might be local businesses. I've got a bit of a variety. This is usually radios for testing and connecting with yeah, when I'm testing on site. So yeah, that is how you do it. So so we've read this radio, but also I've shown you how the programming screen and how you would go about programming. It's only been a simple demonstration, but that's how simple it is. It's literally all computerized. Right. Okay. So yeah, it's Craig from YesWay Communications in Lincoln. And yeah, hope it's been useful to you. Have a good day. Bye.